Hello, everybody who is listening to this video, watching this video. We're going to go through these notes. These are notes for the next step in our arithmetic and geometric sequences. So this first sequence that I'm looking at right here, this first sequence is an arithmetic sequence. How do I know that? Well, I'm looking to see what am I adding each time. Now, sometimes it's hard to find out what I'm adding each time, so if I come off to the side, I'm going to find my common difference, because that's what I'm adding each time, and I'm going to take my second number, and I'm going to subtract my first number. So my second number in this situation is a -5, and I'm going to subtract a -9. I highly recommend you use your calculator for something like this, and your calculator will let you know that you are adding for each time. So I'm going to write this as a +4, +4, +4, etc., etc. I'm going to put these numbers into my table. So this is a -9, -5, -1, 3, and 7. And I'm going to graph those points off to the side. So 1 is at a -9, 2 is at a -5, 3, -1, 4, 3, and 5, 7. So I'm going to connect all these points. My line is not great. Let's try that again. Connect these points. I don't know that that's much better. But that's okay. It doesn't need to be exactly perfect. So here is my line of this sequence. So is that arithmetic or geometric? Well, we just talked about it being arithmetic because we're going to add the same number each time. If I'm adding, that means I have a common difference of +4. Now, we talked about this a little bit before. I know you've done some notes on this, but it's been a while. What kind of a line is this? A lot of people are going to say it's a straight line, and you're absolutely right. But the function family that it belongs to is our linear family. So anytime I have an arithmetic function, I'm going to have a linear graph. Now here's my second example. I'm going to look at this sequence, and oh, these numbers are getting really big really quickly. So I'm going to see if I can find my common ratio, because that's what happens when my numbers get really big really quick. I'm going to take my second number, or the numbers can get really small really quickly. My second number divided by my first number. So in this case, my second number is a 2, and my first number is 2/3. If you put that into your calculator, you should get 3. I highly recommend practicing in your calculator with these. If you're looking at this fraction though and you're like, oh my gosh, I don't like fractions, great, you can look from 2 to 6. How do I get from 2 to 6 and 6 to 18 and 18 to 54? You might automatically see that you're multiplying by 3. And if that works best for you and you're able to see that that's timesing by 3, awesome. I'm going to put all of these numbers into my table. So I get a 2/3, 2, 6, 18, and 54. And then I need to graph that over here. Now this first one, I'm graphing 1 2/3. So I go to my x-axis, here's my 1. But if you notice on your y-axis, we're actually skip counting by 2s here. So 2, 4, 6, 8, 10. And this is a 2/3. Where is my 2/3 going to go in this problem? Well, I know that 2/3 is between two whole numbers of 0 and 1. If you wanted to, you could put that in your calculator and you get 0.6 repeating as your decimal. But I know that 2/3 or 0.6 is between whole numbers of 0 and 1. So I'm just going to put that first dot way down there. As long as it's somewhere between that 0 and that 2, just above that x-axis, that's a great place to have that point. Now if my x is 2, my y is 2. When x is 3, my y is 6. 4 goes to 18. And 5, I get way up here at 54. And I'm going to try and connect those points as well. Now, since we are multiplying each time, we're multiplying by 3 to get to our next numbers. This is a geometric sequence, which means it has a common ratio. Ratio just means that we're multiplying each time, and I'm multiplying by 3. So what function family does this graph represent? Well, it is a curve, so it's not linear. If you remember this from our notes from several weeks ago, this is an exponential graph. An exponential meaning that it has that curve. This is a J shape or a smooth curve. Anytime you see exponential, that means it's going to be a geometric sequence. All right, time to move to the back. So I've got match each graph with its, or each sequence with its graph. So I'm looking this one. I've got 4, 7, 10, 13. What are you adding or multiplying each time? Well, it's going up by the same number each time. I'm adding 3. So I do have a common difference here. My common difference is 3. And I'm looking at my graphs. Where do I have numbers 4, 7, 10, 13, 16? So if I look at graph 1, oh, I do have one at 4, but then this goes to maybe 8 and then 16, which doesn't match. But this one, I've got my 1 is 4, or when x is 1, y is 4. Then I have, oh, that could be 7, 10, 11. So this one works really, oh, sorry, not 11, 13. So this one works really well with graph number 2. If you haven't had a chance to try some of these other problems, pause your video for a moment, try them on your own, and then answers will show up in just a minute. So for this next one, I'm multiplying by 2 each time. So I have a ratio because I'm multiplying by 2. And if I'm multiplying, remember, we had a certain kind of curve that's going to happen. So I have 4, 8, 16, 32. Oh, this one, 4, 8. Here's my 16 right over here. That's about at 16. And 32. So this matches with graph 1. Then I have 125, 25, 5. Ooh, this one's a little bit tricky. So if you're looking at this, you're seeing that it's decreasing, but I know that if I'm decreasing, I still have to multiply by something. And I'm multiplying, in this case, I can find my common ratio. I take my second number divided by my first number. So my second number is 25 divided by 125. If you put that in your calculator, it's going to give you 0.2, which would be a fraction of 1/5. But also if you're looking at this and you see, oh, I'm dividing by 5 each time. Don't forget that fractions literally just mean divide. So this is saying that I am dividing by 5. So that's something else you could use as well. So my ratio is 0.2 or 1/5. Sorry, my pen is being a little weird. 0.2 or 1/5. And which graph is that? Well, I know it's decreasing, and I'm multiplying each time, so I know it has to be this. In case it's not a J shape this time, it's an L shape, but it's got a curve to it. It's not a straight line. So this would be graph 4. Then this tells me this has to be graph 3, but why is it graph 3? Well, if I'm going from 11 to 5, I can see that I'm subtracting 6. But if you can't see that right away, remember you can do common difference equals your second number minus your first number. And that'll tell you that you are subtracting 6 each time. And it's a common difference. All right, last but not least, I need to write a sequence that has a first term of 5, a common difference of 3/4. So I'm going to put 5 right here. That's my first term. Then I need to, since it says difference, I need to add 3/4. You could literally just put that in your calculator. Don't forget that you have a fraction button of n/d, and you can use that to put this 3/4 into your calculator. When you put that in your calculator, you should end up with a 23/4. Then you would do it again, and you're actually going to get 16/2 because it's going to simplify. At the end, you have to put these dots. If you don't put the dots, that is going to actually be an incorrect answer. So the dots mean that this sequence continues. It's not just going to stop at 16/2. We'll do the same thing with number 5. We're starting. My first term is -2. I have a common ratio. Ratio meaning I am multiplying by -5. So -2 times -5 is going to be a positive 10. Positive 10 times -5 is going to bring me back to a negative number. I'm going to keep going with this sequence. -50 times -5 is going to give me a positive 250. And then I end up with a negative 1250 after that. Make sure you put the dots at the end. So if you notice when you have a negative ratio, you're going negative, positive, negative, positive, negative. So thanks for staying with me for this whole video. You're also going to have some extra notes that you can watch a video for and some